Is this a Starship Flight? The XZY-1 rocket, recently tested by Chinese startup Space Epoch. On May 29th local time, or 4:40 p.m. Eastern on the 28th, the company carried out a vertical takeoff and vertical landing test at the Haiyang spaceport. The purpose of this test was to verify the basic flight and recovery capabilities of the vehicle, similar in spirit to the SN series suborbital flights SpaceX conducted during early Starship development. However, by relying on an established design, Space Epoch has taken a shortcut and pushed forward with a more refined first demonstration. The test was straightforward. The XZY-1 lifted off from a static test stand, flew to an altitude of 2.5 kilometers, and then performed a controlled descent to a splashdown in the adjacent bay. According to the company, the flight lasted 125 seconds in total. The sequence of events, including full engine ignition, throttling during ascent, engine cutoff at apogee, reignition of the center engines, and soft water landing, closely mirrored the early Starship SN flights. Based on available video footage and company statements, all these steps were carried out successfully. This wasn't just a simple demonstration. The entire exercise was clearly aimed at showcasing Space Epoch's ability to replicate SpaceX's VTVL maneuvers, specifically water-based recovery. While SpaceX has conducted a handful of Starship water landings, some successful, others less so, Space Epoch's test was conducted at a much lower altitude and closer range. Comparing the two programs directly isn't entirely fair, as SpaceX is working with near-orbital trajectories and recovering vehicles from the Indian Ocean, while XZY operated within a narrow vertical range. Still, the operational similarity between the tests illustrates just how closely Space Epoch is following in Starship's footsteps. After splashdown, the XZY-1 was recovered by ship. Images from the recovery process show that the rocket appeared to remain largely intact. However, one crucial detail remains unclear. The aft section, where the engines are located, was submerged during recovery. Without clear post-flight images or inspection data, it's impossible to say with certainty whether the engines survived the landing intact or sustained damage. Space Epoch will need to release more technical documentation or imagery to confirm the condition of the vehicle's most important systems. Nonetheless, the company's ambitions are undeniable. Space Epoch clearly has its sights set on reusability and likely full reusability in the long run, something that very few companies outside of SpaceX have even attempted. Their designs also leave little room for doubt about their inspiration. The XZY-1 test vehicle stands 26.6 meters tall and measures 4.2 meters in diameter, about half the size of Starship. Its polished stainless steel exterior is unmistakably similar, as is the choice of propellant, a Methalox engine system using liquid methane and liquid oxygen. The rocket's thrust reportedly reached 57 tons during this flight, and its engines are intended to be reusable. The only distinct design difference lies in the fins, which appear to be narrow and blade-like rather than the wide control flaps seen on Starship. Following the successful VTVL test, Space Epoch has set its sights on orbital flight within the year, an ambitious goal, especially for a startup. If they succeed, they aim to launch up to 10 tons to low Earth orbit using a reusable variant of the XZY-1. Notably, this would represent a payload class higher than Starship's demonstrated capabilities to date, though Starship's design aims to far exceed that once operational. What many might not realize is that this test was not the first major milestone for Space Epoch. As early as 2023, the company was already generating buzz for building a full-scale rocket prototype that bore a striking resemblance to Starship. That version stood 64 meters tall, had a total mass of 515 tons, and was also made of stainless steel. Its design included a tapered nose cone and cylindrical body, and it too used Methalox propellant. That same year, Space Epoch conducted a 70-ton thrust static fire and performed a water drop test to simulate recovery stress. Plans were also announced to recover the booster using a tower system similar to SpaceX's Mechazilla catch towers. According to a 2023 investor briefing, the full-scale rocket was designed to deliver 6.5 tons to a 1,100-kilometer orbit, support 20 reuses, and fly up to 25 times per year. To fund development, the company raised 200 million yuan, or about $28 million in November of 2023. At the time, the prototype appeared crude, visible rivets, rough welds, and incomplete systems. In contrast, the XZY-1 tested in May of 2025 shows clear improvements in build quality, precision, and control, evidence of rapid iteration. But can this Starship clone beat the real thing? Probably not. While Space Epoch and others may showcase reusable capabilities at smaller scales, Starship is targeting full payload delivery to orbit, on-orbit refueling, lunar landings, and Mars missions. Challenges that involve orbital re-entry heating, advanced flap control, tank installation, and rapid turnaround with minimal refurbishment. Copying Starship's exterior is easy, replicating its complex flight-proven systems is not. The real test lies in surviving orbital heat, reliable multi-engine startups, interstage separation, and long-duration guidance, areas where SpaceX has spent over a decade advancing the state of the art. Still, Space Epoch's fast progress is impressive and contributes to global momentum toward reusable spaceflight. But Starship remains unmatched in scale and ambition. Let us know your thoughts on Space Epoch's Starship clone in the comment section down below, and don't forget to like and subscribe to follow SpaceX's journey to the future of spaceflight. As I've emphasized before, Space Epoch and its Starship-like rockets are far from the only examples of SpaceX-inspired designs emerging around the world. In fact, a growing number of aerospace companies, particularly in China, are adopting similar strategies, replicating key elements of SpaceX's designs in their own rockets. One of the most prominent of these is Deep Blue Aerospace. The company is currently working on its Nebula 2 rocket, which bears a striking resemblance to SpaceX's Falcon 9. From the two-stage architecture to the grid fins, interstage payload fairing, and the booster's aft section, the similarities are clear. Even the materials appear to take cues from both Falcon 9 and Blue Origin's New Glenn. Perhaps most interestingly, Deep Blue Aerospace plans to use a launch and landing tower similar to the Chopsticks system SpaceX uses with Starship. In an earlier version, the Nebula 1, the company even combined a Dragon-like crew capsule with a booster to create a suborbital tourism system reminiscent of Blue Origin's New Shepard. Another company following a similar path is Cosmoleap, which is developing the LEAP or Yueqian rocket system. This design merges Starship's stainless steel construction and catch system with the more traditional Falcon 9 layout. To support this ambitious project, Cosmoleap has secured significant investment, signaling strong confidence in their approach. And there's more on the horizon. Landspace, after successfully launching the Methalox-powered stainless steel Zhuque 2, is now turning its focus to Zhuque 3, a fully reusable vehicle that clearly aims to rival Starship. Similarly, Space Pioneer is preparing to unveil the Tianlong 3, which combines design elements from both Falcon 9 and Starship. Even national space agencies are adopting this trend. China's future version of the Long March 9 heavy lift rocket is expected to borrow heavily from Starship's fully reusable architecture. With so many companies racing to recreate SpaceX's success, 2025 and beyond could mark the beginning of a new era in global rocketry, one where imitation isn't just flattery, but a fast track to competition. Clearly, despite the impressive effort to imitate, I believe that Space Epoch's rocket and other Starship copies still cannot surpass the original. While these rockets often attempt to replicate Starship's most celebrated features, they tend to do so in a piecemeal fashion, sometimes even merging elements from different rockets and systems into a single platform. On paper, this might seem innovative, but in practice, these combinations often lack cohesion. Mismatched components can lead to compatibility issues and unintended design flaws. More concerning is the tendency for these efforts to focus solely on the external features of Starship, neglecting the core technologies that make SpaceX's vehicle truly revolutionary. Superficial copying can lead to critical failures during testing and development. A prime example is the Tianlong 3 rocket, which suffered an embarrassing mishap when it unexpectedly lifted off the pad during a routine static fire test, an error that reflects a lack of deeper technical understanding. Even more critically, an over-reliance on imitation can stifle creativity and innovation. When companies or even entire national programs center their strategy around copying others, they risk losing their own technological identity. The result is a short-term gain that undermines long-term sustainability, which is evident in how some companies have abandoned kerosene for methane, switched from traditional materials to stainless steel, and ditched landing legs in favor of catching towers, all in an attempt to mirror Starship. But copying every detail without building the foundational expertise often leads to fragile progress. It's hard to imagine any copycat rocket truly competing. Without unique innovation or the infrastructure to support such grand ambitions, these imitation rockets are likely to fade away as the real Starship continues to define the future of spaceflight. In the coming months, SpaceX must work quickly to help Starship overcome its current limitations and firmly establish its leading position in spaceflight innovation. At present, Starship has yet to fully reach orbit and successfully deploy a payload, a milestone that China's Zhuque-2 has already achieved. To move forward, SpaceX must ensure that the next Starship flight not only reaches orbit but also completes key mission objectives such as deploying demonstration payloads and paving the way for operational satellite deployments, in-space refueling tests, and more. These steps are essential to proving that Starship is more than just a bold concept, it's a fully capable game-changing launch system. Following that, SpaceX's top priority should be mastering the complex landing procedure for both the booster and ship. Successfully recovering both stages using the Mechazilla catching arms will mark the realization of full reusability, a cornerstone of the Starship program and a major differentiator from any of its imitators. During each flight, SpaceX must also continue refining every subsystem, which include engines, propellant tanks, flaps, thermal protection systems, guidance algorithms, and more. Enhancing the reliability of these systems not only improves safety and performance, but also supports rapid reusability, critical to achieving Starship's intended high flight cadence. As Starship approaches operational readiness, SpaceX also needs to take decisive steps toward its longer-term goals, building its infrastructure for lunar and Martian missions. These efforts are vital, especially as China accelerates its own ambitions in deep space exploration. The competition is heating up, and deadlines for major missions like Artemis and Mars cargo flights are fast approaching. Despite the challenges ahead, SpaceX has consistently proven its ability to do what others consider impossible. The team has already landed boosters using Mechazilla arms and even reused one in a recent flight. Tangible proof that their vision is not only feasible but already progressing. Once SpaceX fully masters Starship, it won't just outperform the imitators, it will leave them far behind, solidifying its role as the global leader in next-generation spaceflight. Let's watch closely to see how this historic journey unfolds. Adding to the buzz in the space industry, Elon Musk recently announced that SpaceX plans to phase out the Dragon spacecraft. Why was this decision made? Meanwhile, efforts are also underway to preserve NASA's SLS, Orion, and Lunar Gateway programs. Are these moves truly justified? Let's turn our attention to a surprising and dramatic update involving Musk's Dragon spacecraft. In a move that caught many off guard, Musk recently announced that SpaceX would begin decommissioning its Dragon program, an announcement that has sent shockwaves through the aerospace community. The decision came in response to political tensions between Musk and U.S. President Donald Trump. Historically, Musk and Trump maintained a cooperative relationship, particularly during the presidential campaign and the early months of the new administration. However, that alliance now appears to be unraveling due to recent financial and policy decisions by the White House that have negatively impacted Musk's companies. On the social platform Truth Social, Trump publicly stated, "The easiest way to save money in our budget, billions and billions of dollars, is to terminate Elon's governmental subsidies and contracts. I was always surprised that Biden didn't do it." In a swift and bold reply, Musk posted on X, "In light of the president's statement about cancellation of my government contracts, SpaceX will begin decommissioning its Dragon spacecraft immediately." The potential consequences of such a move are enormous. Dragon has played a vital role in supporting both NASA and the broader U.S. space program. Without it, America would lose its only operational spacecraft capable of carrying astronauts to the International Space Station. At this time, no other American spacecraft is fully certified or available to assume that role. Additionally, Dragon is responsible for a majority of cargo resupply missions to the ISS, a critical task as other vehicles have faced delays or technical issues. Since its inception, Dragon has flown 51 missions, 46 of which have been to the ISS. Its track record speaks volumes. Not only has it provided dependable logistics support, but it has also come to NASA's aid during emergencies. One standout example occurred when Dragon was used to help rescue 2 astronauts stranded on the ISS due to the persistent issues with Boeing's Starliner. In many ways, Dragon has become NASA's most reliable workhorse for low Earth orbit operations. If Dragon were truly to be decommissioned, the U.S. space program would be forced to revisit a scenario reminiscent of the post-space shuttle era, a period during which America relied on Russian Soyuz spacecraft to send astronauts to the ISS. For a nation that prides itself on technological leadership and independence in space, that would represent a significant and symbolic setback. The rift between Musk and Trump doesn't appear to stem solely from budget issues. Tensions have also been inflamed by the recent withdrawal of Jared Isaacman from his nomination for NASA administrator, a move believed to have political undertones. Additionally, Trump's stance on electric vehicles and the controversial Big Beautiful Bill policy have added more friction to their once cordial relationship. It's a sobering reminder that political shifts and policy decisions can deeply affect the trajectory of the aerospace sector, whether we like it or not. However, just as tensions seem to be escalating beyond repair, Musk appeared to walk back his announcement. In response to a message on X encouraging him to reconsider, Musk replied simply, "Good advice, okay, we won't decommission Dragon." This change in tone, while subtle, was a huge relief to those watching the situation unfold. It suggests that despite the political friction, cooler heads may yet prevail for the sake of national interests and scientific progress. Meanwhile, preparations for Dragon's next mission are moving ahead. The spacecraft assigned to Axiom 4, the next private astronaut mission, has already been moved to the hangar at Kennedy Space Center. The mission is currently scheduled for launch on June 10th. For now, cooperation between SpaceX and NASA remains intact, and Dragon continues to serve as the backbone of U.S. access to space. In truth, the future of political relationships, especially at this level, is impossible to predict. But we can all hope that, regardless of political divides, the importance of maintaining America's leadership in space will prevail. If you agree and support America's space leadership, throw down the American flag in the comment section down below. Now, let's turn our attention to the latest developments in the effort to preserve NASA's major lunar exploration programs, the Space Launch System, the Orion spacecraft, and the Lunar Gateway. As previously discussed, the proposed budget cuts from the White House have sparked widespread controversy and concern, especially regarding NASA's future plans. Among the many programs on the chopping block, the elimination of NASA's deep space systems like SLS, Orion, and the Lunar Gateway appeared to have garnered the most support from those backing the cuts. Other projects, such as space telescopes and the International Space Station operations, stirred more public and congressional resistance. However, in a surprising turn of events, a notable figure has stepped forward in defense of these programs. On June 5th, Senator Ted Cruz, chairman of the Senate Commerce Committee, announced a new legislative package aimed at counteracting the proposed cuts. The initiative includes a proposed $10 billion budget reconciliation bill intended to offset reductions outlined in the White House's plan. This package blends new spending, adjustments to existing budgets, and tax cuts to make room for critical investments. Of that $10 billion total, nearly half, at $4.1 billion, is proposed to go directly toward continuing SLS production, specifically to support Artemis 4 and 5. Though the Orion spacecraft receives a relatively small allocation of $20 million, this funding signals an intention to maintain development for the Artemis 4 mission, thereby confirming a degree of program continuity. This plan directly contradicts the White House's previous proposal, which suggested retiring both SLS and Orion following Artemis 3. Additionally, the package proposes $2.6 billion to complete development of the Lunar Gateway, a project that was slated for immediate cancellation under the earlier budget plan. Overall, this legislative package demonstrates a clear effort to keep NASA's flagship lunar infrastructure programs alive, despite their long timelines, high costs, and questionable efficiency. The remaining funds from the $10 billion plan are earmarked for other essential programs. These include $700 million for the Mars Telecommunications Orbiter, $1 billion for NASA facility improvements, $1.25 billion spread over 5 years to support ISS operations, and $325 million to continue work on the USD orbit vehicle. From a practical standpoint, support for the ISS and related orbital operations seems reasonable given the station's ongoing scientific value and international cooperation. However, the decision to continue investing in NASA's lunar architecture remains controversial. While Senator Cruz emphasized that the package focuses only on the manned spaceflight centers and the infrastructure needed to beat China to Mars and the Moon, the underlying challenges remain. SLS has been under development for more than a decade and has only flown once during Artemis 1. Despite its limited flight history, the program has cost NASA over $10 billion, not including the expenses tied to Orion and the Lunar Gateway. Concerns also remain over the future quality and performance of Boeing-manufactured SLS rockets. Orion, meanwhile, faced several technical issues during its Artemis 1 return, particularly regarding the reliability of its heat shield. As for the Lunar Gateway, critics argue it is overly complex, expensive to maintain, and poorly suited for integration with SpaceX's Starship human landing system. Given these factors, it's worth asking, is it the right decision to continue investing in these legacy systems, or should NASA shift its focus toward more agile and cost-effective alternatives? What do you think? Join the discussion in the comments section and share your views on the future of NASA's lunar programs. Non-stop progress. Booster 16 has been moved, signaling that Flight 10 prep is in full swing. What comes next? Meanwhile, SpaceX launched another Falcon 9, marking a major milestone in the rocket's legacy with new records and ambitious targets ahead. And though Axiom 4 is slightly delayed, excitement for the mission remains high. Flight 9 wrapped up less than 2 weeks ago, but with Elon Musk's optimistic post-flight comments, it's clear that Flight 10 is already on the horizon. The first signs of preparation have already begun. A new beach closure schedule has been posted on the City of Starbase, Texas website, which is expected to serve as the official source for Starship-related closures once Starbase becomes a city. The dates listed are June 5th as the primary test day and June 6th as the backup, with closures running from 7 in the morning to 7 in the evening both days. Such extended closure windows typically signal major testing at the launch site, and at this point, no prototype is more likely to be involved than B-16, which is expected to support Flight 10. In addition to the posted schedule, physical preparations are visibly underway. On the morning of the 3rd of June, the booster transport stand was moved to the Megabay. Later that afternoon, the Megabay doors opened to reveal B-16 positioned at the entrance and ready to move. It's likely that after arriving at Megabay in late March, B-16 completed its engine installation. By the evening of the 3rd and into the early hours of the 4th, B-16 was transported from the Megabay to the launch pad. A few hours after arrival, it was lifted onto the orbital launch mount. The chopsticks were raised and the ship quick disconnect arm was extended, all in preparation for testing. That means we could see the launch site come alive once again in a matter of days. Next up will be a series of static fire tests. B-16 is likely to undergo multiple firings, including a full 33 engine test, followed by a focused test involving 1 or 2 central engines to prepare for the landing burn. Notably, SpaceX had planned to attempt a 2-engine landing with B-14 during Flight 9, but technical issues prevented it. Once these tests are completed, B-16 will likely return to the Megabay for inspections and final integration. Afterward, it will be paired with Ship 36 on the launch pad for the upcoming mission. As for S-36, it recently returned from cryogenic-proof testing conducted in late April. Following this, it underwent various installation procedures, including the fitting of its aft flaps in late May. Around the same time, a Raptor vacuum engine was seen arriving at Megabay 2, suggesting ongoing engine installation. If all goes smoothly, S-36 will be moved to Massey for static fire testing as early as next week. This timeline is plausible, especially given that S-37 has just completed its cryogenic tests and returned. S-36 is expected to undergo multiple static fires as well, including a single engine ignition to verify the ship's ability to relight its engines in space, a milestone that has eluded SpaceX during the last 3 Starship flights. These tests are critical to ensuring full engine reliability and performance from launch through re-entry. If testing and integration go as planned, Flight 10 could happen sooner than expected. Musk has publicly estimated a launch window in 3 to 4 weeks from Flight 9, placing the potential date in the latter half of June. While ambitious, this goal remains within reach. However, there's still a lot of work to be done. On the booster side, Flight 9 showed substantial progress. The booster completed a successful active flip maneuver and handled the boost back burn better than previous flights. However, one engine failed during the landing burn, and the booster ultimately exploded upon impact. This failure appears to have resulted from a steeper landing angle, which placed excess stress on the booster's aft section. The failed engine may also have contributed to the crash. To avoid repeating this, SpaceX will need to conduct thorough testing and inspections to ensure all engines function reliably under flight conditions. The problem in Flight 9 surfaced late in the mission, underscoring the importance of complete end-to-end testing. Increasing test difficulty while maintaining reliability will be essential. The ship side presents even greater challenges. During Flight 9, the vehicle successfully achieved orbital ascent, demonstrating improvements in its thermal and structural systems. SpaceX now needs to build on that success. One area requiring immediate attention is the PES door mechanism, which failed to deploy the payload as intended. Engineers will need to ensure smoother, more reliable operations for this system in future flights. Engine preparations for in-space reignition and the landing phase must also be addressed. If necessary, underperforming engines may need to be replaced, similar to what was done with S-35. The fire suppression and cooling systems will also require upgrades to respond more rapidly to heat-related issues. Key systems like the heat shield and flaps must be maintained meticulously to ensure the vehicle survives re-entry. The aft flap in particular suffered damage in Flight 9 due to loss of control late in the mission. Likewise, the internal fuel tank system needs reinforcement to prevent leaks and pressure anomalies that could compromise flight stability. Beyond the vehicle components, ground systems must also be enhanced. The launch tower and Mechazilla arms must be fully ready to attempt a future catch. One of the most critical support components is the booster quick disconnect, which experienced significant damage during the last mission. Burn marks, melted surfaces, and structural degradation all suggest that repairs and improvements are urgently needed. Given all of this, do you think SpaceX can realistically launch Flight 10 before the end of June? Type yes or no in the comment section down below. Then don't forget to like the video and subscribe to our channel to continue following SpaceX's exciting journey to revolutionize spaceflight. Now let's turn our attention to SpaceX's special anniversary mission. At exactly 7:40 p.m. Eastern or 4:40 p.m. Pacific on June 4th, SpaceX successfully launched a Falcon 9 rocket from Space Launch Complex 4E at Vandenberg Space Force Base in California. The mission carried 27 Starlink satellites into orbit, further expanding SpaceX's growing satellite internet constellation. Shortly after the launch, confirmation came in that all 27 satellites had been successfully deployed. The mission's booster, B-1063, achieved yet another remarkable milestone by landing on the autonomous drone ship Of Course I Still Love You stationed on the Pacific Ocean. This marked the 26th successful landing for B-1063, highlighting the booster's continued reliability and durability. What makes this mission even more special is its timing. It coincided with a major milestone in SpaceX's history, the 15th anniversary of the first Falcon 9 launch. The inaugural mission occurred on the 4th of June 2010 from Space Launch Complex 40 in Florida. While the initial launch met its mission objectives, the booster did not survive re-entry due to parachute failure. Still, it marked the beginning of what would become one of the most successful rocket programs in history. Reflecting on this, SpaceX posted on X, Falcon 9 lifts off from Pad 4E in California on the 15th anniversary of its first launch. It's astonishing to consider how far SpaceX has come in just 15 years. The Falcon 9, along with the broader Falcon rocket family, has become a cornerstone of the modern space industry, known for its reusability, reliability, and rapid launch cadence. This recent mission also achieved several other significant milestones for the company. Notably, it marked SpaceX's 50th Starlink launch of 2025, continuing the company's aggressive efforts to expand global broadband coverage through its satellite network. Perhaps more impressively, the flight was the 500th mission conducted by the Falcon rocket family, which includes the Falcon 1, Falcon 9, and Falcon Heavy. Reaching 500 flights is an extraordinary accomplishment and a testament to the engineering, innovation, and operational excellence that SpaceX has brought to the industry. Few, if any, other rocket systems in history have come close to achieving this number of missions. Even more notable is the high success rate across these 500 launches. This track record of reliability has made Falcon rockets the preferred choice for commercial customers, government space agencies, and international partners alike. The frequent use of reusable boosters has also set new standards in cost efficiency and launch turnaround times. In fact, SpaceX has demonstrated an average launch cadence of roughly one mission every 2 days, with some missions taking place just hours apart, a level of operational tempo that no other launch provider currently matches. Looking ahead, SpaceX shows no signs of slowing down. With 170 missions planned for this year alone, the Falcon rocket family continues to serve as the company's primary workhorse, even as attention grows around the development of the next generation propulsion Starship system. These recent milestones serve not only as a celebration of past achievements, but also as a foundation for even greater ambitions. As the company continues to push the boundaries of space technology, the Falcon rocket family remains a shining example of how persistence, innovation, and a vision for the future can transform an entire industry. So as we reflect on 15 years of Falcon 9 history and celebrate 500 total Falcon missions, we can only imagine what SpaceX will accomplish next. So stay tuned to see how the company tackles its ambitious goal of 170 launches this year and what new milestones await just over the horizon. Next, let's move on to the latest updates on the Dragon Axiom 4 mission delay. The next crewed mission to the International Space Station has once again been postponed. Axiom Space recently announced on X that the new target launch date for the Axiom 4 mission is now June 10th at 8:22 a.m. Eastern. The mission will still be launched aboard a SpaceX Falcon 9 rocket from Launch Complex 39A at NASA's Kennedy Space Center. However, this time Axiom Space did not provide a specific reason for the delay. This new date marks a 2-day slip from the previously scheduled June 8th launch. Notably, June 8th was already a rescheduled date, as the mission was initially planned for the 29th of May. NASA had explained that the original postponement was intended to allow additional time for finalizing mission plans, ensuring spacecraft readiness, and coordinating logistical requirements. Interestingly, the Axiom 4 mission is expected to use a new prototype of the Dragon spacecraft, which could be a factor in the meticulous preparation process. The Axiom 4 mission is shaping up to be a historic milestone in multiple ways. For the first time in history, astronauts from India, Poland, and Hungary will live aboard the ISS. In addition, it is one of the most diverse crews ever assembled for a space mission. The crew includes Peggy Whitson as mission commander. As a former NASA astronaut, Whitson holds the record for the most cumulative time spent in space by an American. She now serves as Axiom Space's director of human spaceflight. Accompanying her are pilot Shubhanshu Shukla from India, mission specialist Slavits Uznansky of the European Space Agency from Poland, and mission specialist Tibor Kapu from Hungary. Once landed, the crew will travel to the ISS aboard the Dragon spacecraft. They are expected to spend approximately 2 weeks on the station, during which they will conduct up to 60 scientific experiments. These experiments will not only contribute to global scientific knowledge, but also provide valuable operational experience for future private space station missions. Given the significance of this mission for Axiom Space, international partners, and the broader commercial spaceflight community, every aspect of preparation must be executed with precision. As we await further updates, all eyes remain on this groundbreaking mission and the unique opportunities it presents for space exploration and international collaboration. Loss of control, payload deployment failure. These are the key reasons Flight 9 has made headlines. Despite clear progress over past missions, serious challenges remain, and that's exactly when new solutions start to emerge. So what went wrong in Flight 9, and how will SpaceX fix it? Flight 9 concluded with several remarkable moments, and the highlight was certainly Starship's upper stage, referred to as the ship. This part of the flight considered the most critical in determining the mission's overall success, especially after 2 consecutive failures in previous attempts. At first, things looked promising. A major challenge during liftoff was successfully overcome, offering hope for a successful mission. However, as the flight progressed, a series of issues began to unfold. These included the failure to deploy the payload, and more critically, the ship eventually lost control. Let us explore these problems in greater detail. One of the most persistent issues that SpaceX has not yet been able to fully resolve is fuel leakage. Musk confirmed after the flight that a leak occurred in the fuel tank, which led to a drop in pressure and an inability to deliver adequate fuel to the engines. This leak did not appear as a momentary problem. Instead, it began early in the flight, well before the payload deployment phase. The result of this leak was that one engine became underpowered just before the second engine cut off. This led to a partial loss of control. Although the deviation was subtle at first, it became more evident when the internal camera switched to the payload bay. Frost particles were seen drifting in a single direction, which suggested that the entire ship had begun to spin abnormally. As the situation worsened, we witnessed the clear signs of the ship losing full control. In a situation like this, the obvious priority is to regain control of the vehicle. Typically, the first approach would be to reignite the engines and use thrust to stabilize the rocket. However, this option was not available due to the fuel leak that had already reduced engine performance. Instead, SpaceX opted to control the vehicle using the pressure from exhaust gases. This technique uses the natural pressure generated by heated fuel turning into gas within the tank. The expansion of this gas not only helps deliver liquid fuel to the engines, but also provides a means of steering the vehicle. However, the effectiveness of this system depends on maintaining stable internal pressure. Once again, the leak compromised this method. With reduced pressure, the use of the exhaust gases for control was no longer possible. This rendered all recovery strategies ineffective and forced the mission into failure. This underscores how a single leak can cascade into a major failure. It prevents normal engine operation, disables backup control systems, and ultimately compromises the vehicle's integrity. Leaks were also a concern during Flight 7 and 8. On Flight 7, a leak was caused by strong harmonic reactions in the engine's upper compartment. In Flight 8, the issue stemmed from a hardware failure. While those specific problems were addressed, Flight 9 proved that leaks remain an unsolved vulnerability in the Starship system. Now let us return to another issue that occurred even before the loss of control. Viewers who were watching the live camera feed from inside Starship's payload bay were hoping to see the deployment of payloads. But as the expected timeframe passed, nothing happened. It was later confirmed that the payload door failed to open. This malfunction led to speculation that the door had become jammed. Although the door was upgraded compared to the earlier Flight 3 version over a year ago, it is still believed to be relatively unstable. The main reason for this is that the door is not reinforced with structural bars and instead relies on a less permanent mounting method. Another issue is the pressure system. Since Starship is not pressurized during flight, there is not enough force to hold the door tightly against the main body. This causes the door to remain loose, making it harder for the actuation system to perform clean open and close operations. The result is a risk of jamming, or worse, damage to the door's mechanical systems. Several additional factors may have contributed to this failure, including microgravity in space, uneven pressure from leaked fuel entering the payload area, welding techniques that may not have been ideal for vacuum conditions, and other environmental stresses. We should also take another look at the engines. While there was notable progress compared to earlier flights, one serious issue still remains: fire around the Raptor engines. This fire may have also originated from a fuel leak that ignited. Although it did not directly impact the success of the flight, it presents a significant threat to future reusability, which is a key goal for Starship. In an effort to resolve this, SpaceX had previously implemented an upgraded nitrogen purging system. This system is designed to flood the engine area with nitrogen gas to push out any lingering oxygen and methane, thereby preventing combustion. However, the flames seen in Flight 9 suggest that this fix has not yet been sufficient. These incidents collectively highlight just how complex and difficult spaceflight development truly is. Although the Starship program has achieved many significant milestones, persistent issues such as fuel leaks, control loss, engine fires, and mechanical failures continue to pose serious challenges. Have you noticed any other issues during the flight? Share your thoughts in the comment section down below. Then be sure to like this video and subscribe to our channel so you can continue following SpaceX's journey as they work to make space travel more reliable, more affordable, and more exciting than ever before. Once the problems have been clearly identified, the next logical step is to develop effective solutions. The most urgent issue to address is the persistent fuel leakage. As previously discussed, this is an extremely complex challenge, especially in the harsh and unpredictable conditions of space. While a permanent fix may still be a long-term goal, the immediate priority should be to minimize the occurrence and impact of such leaks. One practical approach would be to add protective or secondary reinforcement layers to vulnerable components. These would include fuel tanks, manifolds, and critical piping systems. These layers could help reduce the chances of leaks occurring in the first place. Alternatively, SpaceX could design and implement an automated sealing mechanism that would detect and quickly plug any leak as soon as it is identified. While the development and implementation of such a system would not be simple, it could drastically improve the Starship's reliability during flight. In tandem with addressing leaks, the control system of the vehicle must also be improved. Currently, SpaceX relies heavily on methods such as engine thrust vectoring and exhaust gas pressure to adjust the vehicle's orientation. However, these techniques are highly susceptible to failure when fuel flow is compromised. To ensure consistent control in such scenarios, it may be beneficial to introduce a dedicated backup control system. For example, a small auxiliary thruster or booster could be installed to activate only when abnormal tilting is detected. This would help correct the ship's orientation in emergencies. On the other hand, SpaceX could look into integrating a mechanical solution such as a flywheel system. Flywheels are used in many aerospace applications, including satellite attitude control and telescope alignment. This system relies on momentum and can adjust the vehicle's orientation without consuming fuel. By spinning a flywheel in the opposite direction of the undesired yaw, the spacecraft can counteract the tilt and regain balance. This passive, fuel-free method would be both efficient and less prone to failure under fuel constraints. In extreme cases, if the ship becomes uncontrollable, it would be advantageous for Starship to have a built-in capacity to exploit atmospheric drag. Combined with aerodynamic flaps, the vehicle could potentially use Earth's atmosphere to guide itself back into a stable trajectory, slow down, and increase its chances of a safe re-entry and recovery. Next, let us consider the issue of fire suppression. While nitrogen purging systems are already in use, they clearly need to be strengthened. These systems must be able to act more quickly and effectively when any fire is detected. Another idea is to integrate a water cooling system generated from onboard oxygen and methane, which could help in quickly reducing heat buildup around the engines and extinguishing potential fires. However, as helpful as they may be, they still count as stopgap measures. To truly address the recurring engine issues, SpaceX will need to accelerate the transition to the Raptor 3 engine. Although the Raptor 2 has seen many upgrades, it remains a highly complex engine with delicate and failure-prone components. Raptor 3, by contrast, is designed with a simplified architecture, improved integration, and more durable construction. Sensitive flanges have been eliminated or replaced by more stable welded joints. Additionally, this engine version includes improved internal cooling systems which can better handle high heat conditions and reduce the risk of fire. SpaceX has already conducted more than 300 test firings of the Raptor 3 engine. It is expected to be introduced officially with the V3 version of Starship. However, early integration of Raptor 3 into the final prototypes of Super Heavy V1 and Ship V2 could provide valuable test data ahead of full-scale deployment. As of now, production of the first V3 booster, designated B-18, is already underway inside the Megabay. The first V3 ship, designated Ship 39, is waiting on the completion of earlier prototypes. If everything progresses smoothly, both vehicles should be completed within the next few months, with full testing beginning shortly thereafter. If these tests prove successful, we may see Raptor 3 fly by the end of this year. Another critical issue involves the payload door mechanism. To ensure reliable operation, the door needs to be reinforced with more rigid structural bars, securing it firmly to the ship's main body. Additionally, the actuator system must be recalibrated and positioned in a way that offers both strength and flexibility for repeated open and close cycles. Continuous testing of this door system must also be performed throughout ground operations to catch any potential failures before launch. This includes repetitive motion trials under varying pressures and temperatures to replicate flight conditions as closely as possible. While solving these major problems is essential, it is equally important that SpaceX continues to maintain the successes achieved during Flight 9. These include a smooth liftoff, excellent engine coordination, a flawless stage separation sequence, strong heat shield performance, and the impressive catch of the booster using the Mechazilla arms. These milestones should now be treated as the baseline performance standard for every upcoming mission. The upgrades implemented in Flight 9 already played a vital role in avoiding the setbacks seen during Flights 7 and 8. With this momentum, SpaceX is in a strong position to implement the necessary changes and strengthen future flights. At this very moment, hardware for Flight 10 is undergoing testing. As more information becomes available, We will continue to follow the progress and bring you the latest developments, so stay tuned for what is next in Starship's journey. It is clear that the next phase of SpaceX's Starship development is absolutely critical. Several complex and persistent issues must be resolved in order for Starship to move beyond the prototype stage and become a truly successful operational vehicle. However, there is also the moment when innovative solutions are most often born. SpaceX's engineering team has demonstrated time and again that no challenge is insurmountable. Their creativity, precision, and determination have allowed them to overcome setbacks and achieve remarkable milestones. Flight 10 stands as the next big step forward, one that could unlock a series of vital missions. Let us watch closely to see what new breakthroughs will lead the way. Things get any worse. Blue Origin is experiencing significant challenges in its first year aiming for orbital flight. Not only is there a noticeable delay in progress with its New Glenn rocket, but the company is also showing signs of internal instability during a critical time. So, what specific issues is Blue Origin dealing with, and how might these problems impact the company's future, both in the short term and over the long run? Blue Origin entered 2025 with great determination, kicking off what was expected to be the most exciting year in the company's history with the inaugural flight of New Glenn. The event marked a major milestone, signaling the company's readiness to compete more aggressively in the space launch industry. The results of that first mission were promising, and Blue Origin appeared eager to push forward toward even more ambitious goals. However, nearly 6 months have passed since that initial flight, and instead of continued progress, what we have seen is a growing list of challenges that raise serious concerns about the company's direction and stability. One of the most pressing and potentially long-lasting issues is the matter of human resources. At the end of last month, Blue Origin CEO Dave Limp announced an organizational update that revealed a significant change in the company's leadership structure. Among the most notable changes was the retirement of Linda Kova, a senior vice president who played a crucial role in managing Blue Origin's engine programs, particularly the BE-4 engine. Although the company stated that this retirement had been planned for some time and that the transition would not affect engine development, the reality is not so simple. Leadership changes at such a senior level often lead to at least some disruption, especially in critical areas like engine production. The BE-4 engine has long been criticized for its slow development and production pace. Now, with launch demand increasing for both Blue Origin and its commercial partners, any instability in this department could have ripple effects that jeopardize future missions. Even more concerning is the upcoming departure of another key figure at Blue Origin. Jarrett Jones, the senior vice president overseeing the New Glenn program, is reportedly set to retire on August 15th. This date is significant for more than one reason, as it is also the scheduled launch date for New Glenn's second mission. Given the central importance of the New Glenn program to Blue Origin's long-term strategy, the loss of its top leader at such a crucial time raises questions about continuity, momentum, and team morale. Although both retirements are described as planned and amicable, the timing is difficult to ignore. Having two senior executives step down while their respective areas are in pivotal phases of development is highly unusual. It inevitably raises speculation about possible internal disagreements or a lack of alignment within the company's leadership. At this point, there has been no public confirmation of any internal conflicts, but the situation will require close attention. In the meantime, Blue Origin faces the immediate challenge of finding qualified replacements and ensuring that both the engine and launch vehicle programs continue without major disruptions. While all this is happening behind the scenes, the company is also trying to maintain public confidence by sticking to its updated launch schedule. Dave Limp recently announced on X that New Glenn's second mission, titled Never Tell Me the Odds, is planned to launch no earlier than the 15th of August. This flight will mark the final contribution of Jarrett Jones before his departure, making it a symbolic and pivotal moment for Blue Origin. The announcement of a clear date has been welcomed by followers of the space industry, especially after months of vague projections. However, it also highlights a gap in execution. The first New Glenn flight took place in January, and if the second one does not launch until mid-August, that would mean a 7-month interval. While such a gap is understandable for a new rocket still undergoing refinement, it falls short of the ambitious goals previously laid out by company founder Jeff Bezos. At the start of the year, Bezos expressed an intention to launch up to 8 flights in 2025, which would require one launch every 1 to 2 months. Based on current developments, that goal now appears to be out of reach. In fact, according to recent reports, Dave Limp admitted during an internal meeting that the company is unlikely to meet its target this year. At best, Blue Origin might be able to carry out one more flight beyond the one scheduled for August. Even that modest outlook is not guaranteed. There are several factors that could lead to delays, making the timeline for the second mission uncertain. Technical challenges, supply chain constraints, and leadership transitions all contribute to an atmosphere of unpredictability around Blue Origin's plans. In summary, 2025 was supposed to be a breakthrough year for Blue Origin. The company started strong with the successful debut of New Glenn, but it now faces significant headwinds. Leadership turnover, ongoing technical challenges, and the inability to meet projected launch rates are casting a shadow over its ambitions. The next few months will be critical in determining whether Blue Origin can recover its momentum or whether these setbacks will lead to a broader slowdown in its progress. So far, the most notable progress on the second New Glenn mission has been the arrival of the second stage, which was delivered in early April. Later that same month, Blue Origin CEO Dave Limp revealed that a successful hot fire test had been conducted. The test lasted for 15 seconds and demonstrated improved performance from the BE-3U engines, with thrust increasing from 173,000 pounds to 175,000 pounds. Earlier in late March, the company announced that it had completed the mishap investigation required by the Federal Aviation Administration. The causes of the first mission's issues were disclosed, and Blue Origin was directed to implement corrective measures. At that time, the company expressed confidence in launching its next mission in the spring. However, with the schedule now shifted to August, there are still about 2 months left before the targeted launch date. This period will likely be dedicated to preparing key components for the mission, including the booster rollout and testing, integration of the upper and lower stages, payload rollout and installation, and other final preparations. The booster is currently the area drawing the most attention. It was the component that experienced problems during the previous flight, and according to the FAA-related update, 3 BE-4 engines failed during the landing burn. Additional issues such as propellant management and engine bleed control were also identified. These problems are not minor, and correcting them has likely contributed to the delayed timeline. Once the issues are addressed, Blue Origin will need to install the updated engines, roll out the booster, connect it with the second stage, and begin a new round of tests to ensure system readiness. Following testing, payload installation will begin. This mission could potentially carry 2 payloads. One possibility is NASA's Escapade spacecraft, which is already complete and was originally scheduled to fly with New Glenn last year. The other option is the Blue Moon Mark I lander, a lunar payload developed in partnership with NASA. Given the current pace of operations, it is likely that only one of these payloads will fly this year. Regarding the mission's goals, Dave Limp has stated that Blue Origin still intends to land and recover the booster. In addition to deploying the NASA payload successfully, both objectives will present significant challenges. Landing a booster on a drone ship remains extremely difficult, and to date, only SpaceX has successfully executed this maneuver. In his own post, Dave Limp noted, "This will take a little bit of luck and a lot of excellent execution." The payload deployment phase is also expected to be more complex than that of the first flight. Unlike the dummy payload used previously, this mission involves real, high-value payloads. Escapade and the Blue Moon lander both carry important objectives. A failure in this phase could compromise the payload and risk the success of their respective missions. In addition to preparing for this launch, Blue Origin is aiming for an ambitious production goal of 8 GS2 second stages this year. This aggressive target suggests the company is preparing for a more frequent launch cadence in the near future. However, considering the company's current struggles with production delays, missed launch targets, and recent senior leadership changes, meeting this goal appears increasingly unlikely. Rapid production also raises concerns about quality assurance, especially since the second stage components were the subject of repeated issues during testing in the previous year. Despite these concerns, the focus now turns fully to the second New Glenn flight. The next 2 months will be critical for Blue Origin. The success of this mission could restore momentum and confidence, but it'll require precise execution on every front, from booster performance to payload deployment. Do you think New Glenn can launch on schedule, and do you believe the mission will be a complete success? Respond with yes or no in the comments section down below. Then, like the video and subscribe to our channel to continue following SpaceX's development journey and all the latest in spaceflight. Overall, the ongoing problems and delays are putting Blue Origin at risk of falling significantly behind in the competitive space industry. One clear example is the Mars spacecraft payload, which was originally scheduled to launch last year. Due to New Glenn's lack of readiness, that launch has been postponed. Since launch windows to Mars occur only once every 2 years, this delay will have lasting effects on mission planning and timelines. Looking ahead, New Glenn is expected to carry the weight of several major projects. A primary responsibility is supporting Amazon's Project Kuiper, with as many as 30 satellite launches planned. This is especially notable because Amazon, like Blue Origin, is owned by Jeff Bezos. In addition, New Glenn is set to participate in numerous national security space launch missions after being selected for both Lane 1 and Lane 2 under Phase 3 of the U.S. Space Force's contract. These missions represent vital government and commercial opportunities that Blue Origin must deliver on to remain competitive. In contrast, Blue Origin's competitors are rapidly moving forward. Compared to SpaceX's Falcon rockets, New Glenn's accomplishments appear limited. More importantly, SpaceX's Starship program has already launched 3 times this year. If all goes well, both Flight 10 and 11 of Starship may take place before New Glenn 2 even lifts off. Flight 10 is almost certain to launch first, and Flight 11 might also beat New Glenn, though it is harder to predict. What do you think? Will Flight 11 or NG2 launch first? Leave your answer in the comments. Beyond launch timelines, it is important to compare mission objectives. Starship has already demonstrated multiple Super Heavy booster recoveries, and SpaceX has even reused one of them. Their focus is now achieving reliable flight performance and ultimately full stage reusability. This is a major step forward in rocketry and sets Starship apart from every other vehicle, including New Glenn. Although New Glenn technically reached orbit before Starship, it is still struggling to match the landing capabilities that SpaceX perfected years ago. Blue Origin may also be outpaced by Rocket Lab, a smaller yet fast-moving competitor. Rocket Lab's Electron rocket continues to break records, and the company is preparing to debut Neutron, a larger, reusable vehicle. Neutron might even launch before the delayed New Glenn 2, which is entirely possible. With slow progress in what should be a foundational year, Blue Origin risks losing its competitive edge. Rebuilding internal strength after the departure of key leaders and delivering a successful second flight are both essential. This next mission is not just a launch, it is a turning point that will determine whether the company can rebound or continue to fall behind. Let's see how Blue Origin responds to these challenges. The race to the moon is heating up. SpaceX has announced the timeline for its first Starship launch from Florida, a major milestone on the road to future moon missions. Meanwhile, Blue Origin has revealed a bold plan for an uncrewed Blue Moon fuel transporter mission, designed to refuel its lunar lander in orbit. Preparations for a future crewed landing are already underway. When will SpaceX launch? What does Blue Origin's new mission mean? And how are these efforts shaping the next era of lunar exploration? We're now halfway through 2025 and questions still remain about whether NASA's contractors SpaceX and Blue Origin will be ready in time for their roles in the Artemis program. However, both companies have recently taken bold steps that could inspire new confidence across the aerospace industry. Let's begin with SpaceX. In a March 3, 2025 update titled Future of Building Starship, SpaceX announced, pending completion of environmental reviews, SpaceX intends to conduct Starship's first Florida launch from LC-39A in late 2025. At first glance, this timeline may seem ambitious, perhaps even overly optimistic. SpaceX has yet to finish its Florida-based launch pad infrastructure, and significant work remains in mastering the Starship launch system itself. But the idea of launching Starship from LC-39A has long been on the table. Back in 2022, SpaceX completed stacking the launch tower at LC-39A. In 2024, the environmental impact statement was released, outlining a proposal to support up to 44 Starship launches per year from Florida. If SpaceX can successfully carry out its first Florida launch later this year, it would mark a pivotal milestone ahead of the Artemis 3 mission, currently scheduled for mid-2027. That would leave about 18 months for the company to conduct uncrewed Starship HLS test missions and establish an orbital refueling architecture. Of course, to achieve this, SpaceX still has a long list of objectives to meet. First, the launch infrastructure itself. SpaceX is working towards supporting Starship from 2 Florida pads, LC-39A and SLC-37. For now, LC-39A is clearly the frontrunner, having already seen substantial development. The launch tower is in place, and construction is underway for an orbital launch mount and flame trench, both modeled after those used at Starbase's Pad B. Still, the timeline will be tight. Construction on Starbase's Pad B OLM and flame trench only began late last year and reached basic structural completion by early May of 2025. That pace may need to accelerate in Florida to meet the goal of launching by year's end. Fortunately, SpaceX now has valuable experience from Starbase to streamline the Florida build-out. As for production capabilities, SpaceX has announced a massive new facility, Gigabay, Florida, to be built near its existing Hangar X, also known as the Roberts Road facility, at NASA's Kennedy Space Center. This towering structure will stand 380 feet or 115.8 meters tall and house over 46.5 million cubic feet or 1.3 million cubic meters of interior space. Inside will be 815,000 square feet or more than 75,000 square meters of working space. Gigabay, Florida will support integration, refurbishment, and production for Starship and Super Heavy V3, accommodating up to 24 simultaneous workstations. In terms of capacity, it's staggering. Gigabay will offer 11 times more working area, 19 more work bays, and double the lifting power compared to megabays at Starbase, currently SpaceX's most advanced vertical integration facilities. Site preparation for the Gigabay has already begun. However, full construction is expected to take until 2026. Until then, early Starships used for Florida missions will still be built at Starbase in Texas and shipped to Florida by barge. In short, the months ahead will be crucial for SpaceX's Florida expansion. The company is aiming for its first Starship launch from the East Coast before 2026 begins, an important step toward building a reliable high-cadence launch site. If successful, it could pave the way for the proposed 44 launches per year and demonstrate SpaceX's readiness to handle Artemis mission requirements. So what do you think? Can SpaceX launch its first Florida-based Starship flight by the end of the year? Drop your answer, yes or no, in the comment section down below, like the video, and don't forget to subscribe to stay up to date on SpaceX's journey to the moon and beyond. In addition to SpaceX, its primary rival and teammate in NASA's Human Landing System program, Blue Origin, has recently made significant and somewhat surprising progress. Known for maintaining a veil of secrecy over its developments, the company is now beginning to reveal more about its lunar ambitions, shedding light on what has long been a mysterious timeline. After winning a $3.4 billion NASA contract, Blue Origin unveiled its Blue Moon lunar lander. While the lander itself was a major announcement, the true revelation came recently with the introduction of a key component that could define the mission's long-term success: the transporter vehicle. During a presentation at the Lunar Surface Innovation Consortium on May 19th, John Kalouris, Blue Origin's Senior VP of Lunar Performance, introduced an illustration of the transporter, a vehicle designed to refuel the Blue Moon Mark II crew lander in lunar orbit. He explained that the vehicle has undergone significant evolution since the contract was first awarded. The illustration revealed a T-shaped design with a relatively long cylindrical body. One end appears to be engineered for docking with the lander, possibly equipped with a fuel pumping system, while the opposite end likely contains the propulsion system. This configuration indicates that fuel will be delivered through a direct transfer system, similar in concept to how SpaceX will refuel its Starship by launching a tanker that docks and pumps fuel directly into the spacecraft. However, Blue Origin's approach goes a step further. Rather than performing refueling operations in Earth orbit, the company plans to transfer fuel in lunar orbit, a much more complex and ambitious endeavor. The transporter will first reach Earth orbit, where it will gather propellant, which includes liquid hydrogen and liquid oxygen, from surplus fuel remaining in the upper stage of its launch vehicle, the New Glenn. These propellants will be stored in tanks within the transporter, each around 7 meters in diameter. To ensure the fuel remains viable for the duration of the mission, Blue Origin is incorporating a zero boil-off technology, a system designed to keep the cryogenic propellants in liquid form by maintaining extremely low temperatures. Specifically, the liquid hydrogen will be kept at around 20 Kelvin, or negative 253 degrees Celsius, while the liquid oxygen will be stored at about 90 Kelvin, or negative 183 degrees Celsius. After fuel aggregation is complete in Earth orbit, the transporter will journey to a near rectilinear halo orbit around the moon. Once there, it'll wait to rendezvous with the Blue Moon lander and transfer the necessary propellant to support its descent and return mission. This strategy allows the lander to preserve all of its onboard fuel for the actual lunar landing, exploration, and return to lunar orbit, rather than using it up in transit from Earth. According to Clone, the transporter will be capable of carrying up to 100 metric tons of propellant from Earth orbit to lunar orbit. Remarkably, with only minimal modifications, primarily to the communication systems, the same vehicle design could carry up to 30 metric tons to Mars orbit. Coloris emphasized the wider implications of this breakthrough, suggesting that it could open up access to the asteroid belt and potentially the broader solar system. He also pointed out that mastering long-term storage of cryogenic fuels like liquid hydrogen and liquid oxygen is a major leap forward in propulsion technology, offering high performance and versatility for missions beyond the moon. This capability also aligns with the vision of using resources harvested from other celestial bodies, such as water ice, which could be converted into usable fuel for future missions. In terms of progress, Blue Origin and NASA have already integrated the first prototype of this fuel transporter system and have begun testing, starting with evaluations in a thermal vacuum chamber. In June, they plan to demonstrate the system's ability to hold cryogenic fuel continuously under stable conditions. By the end of the year, the company aims to begin manufacturing the actual flight units, laying the groundwork for critical upcoming missions. These include both an uncrewed landing test mission using the Blue Moon Mark II and eventually a crewed lunar landing before the end of the decade. Before those major milestones, however, Blue Origin is preparing to launch the first iteration of its lander, Blue Moon Mark I, as early as this year. This version is roughly the same diameter as the Apollo lunar module, but significantly taller, though still about half the height of the Mark II. The Mark I lander will be capable of delivering up to 3 metric tons to the lunar surface. The upcoming mission will carry a camera payload under NASA's Commercial Lunar Payload Services program. The lander is currently being assembled at Blue Origin's facility in Florida and is expected to be ready to leave the factory within 6 weeks. It'll be then transported to NASA's Johnson Space Center for thermal vacuum testing before returning to Florida for launch. The vehicle will fly aboard New Glenn for a 7-day journey to the moon. Meanwhile, Blue Origin is also preparing a second Blue Moon Mark I lander to follow the initial mission, signaling the company's growing commitment to establishing a regular cadence of lunar activity. With these developments, Blue Origin is clearly moving beyond conceptual designs and into tangible progress, aiming to become not just a competitor, but a major contributor to humanity's return to the moon and beyond. Blue Origin has also taken important steps in preparing for its upcoming crewed lunar missions. In collaboration with NASA, the company recently conducted an underwater simulation at the Neutral Buoyancy Laboratory located at NASA's Johnson Space Center. This facility, designed to replicate the weightlessness conditions of space, provided a realistic environment for testing how astronauts will operate on the moon. During the test, divers donned mission spacesuits and carried additional weights to mimic lunar gravity. These participants performed various tasks underwater to simulate the movement and operations astronauts will carry out on the lunar surface. A key focus of the exercise was testing with a full-scale mock-up of the Blue Moon Mark II lander. These exercises, known as extravehicular activities, or EVAs, included assessments of how astronauts would enter and exit the lander and how they might interact with equipment or transport cargo on the moon. Blue Origin emphasized that the mock-up accurately reflected the actual dimensions of the lander's airlock hatch and its close proximity to the lunar surface. Over the course of 2 days, the teams evaluated multiple mission-critical systems. In a statement, the company noted, "We demonstrated our ability to safely deliver astronauts and cargo to the lunar surface and return the crew in an emergency." In summary, both SpaceX and Blue Origin are moving steadily forward with increasingly concrete milestones on their paths to the moon. With this kind of progress, there is good reason to be optimistic that the United States will once again lead in the race for deep space exploration, no matter how fierce the competition becomes. This has been Kevin with Great SpaceX. Don't forget to like the video and subscribe if you haven't already to stay up to date with yours truly on the latest milestones in SpaceX's journey. Thank you so much for tuning in, and remember, curiosity, imagination, and inspiration will follow you so long as you keep looking up.